Hi, this is Richard Wright for Software Bisque again, and welcome to the SkyX LTI Technical Preview. This video is part 3, Focus Pocus, or how to get focused with AtFocus 3. Now, before we dive right into the program, I'm going to give you kind of a little rundown of AtFocus 3 because it is a little bit different than how AtFocus 2 works. When we first started letting some early adopter beta testers have this, one or two of them ran into problems because they kept trying to use it in the same manner that they were used to with AtFocus 2, and it's really a different paradigm altogether. For one thing, there's only one parameter. There's not a whole lot of setup. We just need to know what the search step size is, and what that is how far to move the focuser in steps in order to get a reasonably measurable difference in sharpness on the image. Once we know that, then the algorithm for AtFocus 3 can do all of the driving. Technically, there's also exposure time, which will get longer for narrowband filters and so forth. And right now, there's not much provision for that in the technical preview in LTI, so you will need to manually set that. But you can't make it, in some cases, you can't make it too long. A few saturated stars are actually okay with AtFocus 3. For the time being, we do put that burden on the early adopter testers to set an exposure time sufficient to get some data on there. Now, as far as the search step size goes, there's a characterization wizard. If you know the step size of your focuser, the physical amount of movement per step, and the focal ratio of your telescope, then we can compute that for you. Eventually we'll have a wizard that you just say let me drive, and it'll take some exposures and move the focuser around, and it will figure that out. Also, in the meantime, you can sort of determine this experimentally just by moving the focuser and taking some images. You really don't want a large change, just enough to make the star go from a tiny dot to a large swollen dot, or maybe into a small donut, and then the AtFocus 3 algorithm can do the rest. I'm also exposing the number of samples, so at each focuser position you can take multiple samples, and this can be useful in cases of high noise scenarios, or where there's very little signal in the frame. If it's a very sparse field and there aren't many stars, and what stars there are very dim, then the number of samples can improve the accuracy. This corresponds to the number averages in AtFocus 2, although it's not actually averaging these together. We're using a little bit more sophisticated math model this time around. So I didn't like the term average, but I'm just going to say samples per location. By default, that's 1, and you really can't turn it up more than 3, and that's just to do you a favor. If you need more than 3 samples, then you're not getting enough signal to focus on. You should be increasing the exposure time instead. There's also no steps or range specified, so AtFocus, as long as focus can be achieved, meaning that you can achieve focus with your setup, AtFocus 3 can find it, also assuming that it can get signal. So you're not going to say move 6 units and then it was almost a focus and then you get a diverged error or something. AtFocus 3 knows, it goes, I'm getting closer to focus, and it just keeps going until it gets enough samples around the best focus point to do its computation and then move to focus. A really nice thing about AtFocus 3 too is there's no focus stars, meaning you don't have to slew off and find a particular star and then go back during a series. You can focus on individual stars or the moon and so forth and so on. You can actually focus on anything. It's a frequency-based approach, and it works just fine on stars as well as the moon or planets. Some other very smart people I was talking to when we were first getting this going was like, well, this doesn't work on stars. Yes, it does work on stars, and I know some people have tried to get it to work on stars before and failed, but I didn't use the algorithms that they found on Google. I used something different, and it works very well on stars as well as other objects as well. Now, F-Focus 3 is more than a year's worth of R&D. We didn't just whip this up over the weekend. There's quite a bit of 3 steps forward and 2 steps backwards that occurred on this. And we've tried it with a lot of different focusers, some very sloppy focusers, fast optical systems, slow optical systems, all sorts of different targets. And I've had some users trying it with me as well, and I think we're pretty solid now. It's time to do the technical preview. I'm not saying it's perfect. There may still be some corner cases that need to be addressed, but it is quite robust and usable. And I don't actually ever use F-Focus 2 anymore myself. So the goal here is just point and focus. There's no slewing off during a series. In fact, you can just add a focus run in your series with LTI, and just between filters or after 10 exposures, however you want to set it up, it'll just stop and refocus on your current field without having to move the mount or anything. The search is unidirectional, so if your scope cools off and focus moves forward instead of out, F-Focus 3 is aware that focus keeps getting worse or it keeps getting better, and it'll change directions. It also has auto backlash compensation. You don't have to know how many steps your backlash is. Now it does sort of estimate. It uses a very generous backlash estimation. So if you have a really bad system, then it may not work, but it should work with any well-behaved, and it's important to say repeatable system, and it'll work in either direction. Whether your backlash is if you have backlash going out but not in, but you happen to be on one side of focus, it's fine. It works whichever direction you're going in, and any field can be used. You can point at galaxies or nebula or the moon or a brick wall across the yard if you want to. Now you do have to make sure exposure time is adequate, so that you get enough signal in the image. It will work on single stars, just like F-Focus 2 will. One caveat on that is if you just have one single star, it needs to not be a saturated star. And one of the nice things, of course, is you have a very small subframe around a single star. Then F-Focus 3 is extremely fast. Not any slower than F-Focus 2, certainly. And it works on whole frames or subframes. So you can actually focus on the entire frame, or you can specify just a part of the frame. If you have some saturated stars, that's okay, as long as you haven't picked out one star and it's totally oversaturated. That can cause some issues. There's also a feature where it will automatically find an area in a full frame of best contrast, and then you can set that automatically as a subframe for you. That sort of brings up the question, where's the best place to focus in a frame? Well, you can decide. You can set up a subframe or a region of interest in LTI, and it'll keep that region of interest until the meridian flip occurs. There's also an auto find, which uses the last full exposure to search for a good region of interest. It actually searches the image for the area of highest contrast and says, well, this part of the image has really good contrast. It must be a good place to focus. When the meridian flip occurs, it'll actually do this automatically if you have a subframe set up. If you're focusing on the full image, then when the meridian flip occurs, it just continues using the full image. Now the algorithm does know to stay away from the edges, so it won't pull something where you've got bad coma or something around the edges of your field. And again, you can set this up manually before you start your image run, or you can tell it to do it automatically after the meridian flip. Now, full frame focusing is also available, but you need to be advised if your field is not flat, this is going to give you the best overall focus. So it's going to kind of average. For example, if the middle is really sharp and the edge is fuzzy, then it's not going to give you the best sharpness in the middle of the field. It's not going to give you the best sharpness at the edge of the field. It's going to be somewhere in between. Now, a lot of people like that, and that's actually what they would want. Some people, based on your imaging needs, you may want it to be especially sharp in the middle, and you're going to crop out the edges anyway. So that's kind of up to you in your needs, what you need to do. So that's kind of the rundown. Let's actually jump into LTI now then and see how this all works. Okay, so let's connect to all of our gear, and you'll notice that we're using a Starlight Express one-shot color camera. That's going to become important because for a color camera you should really shoot bend 2x2 when you're focusing. We don't want to try to use the color information. We're just going to shoot bend black and white for focusing purposes. So we'll click Take Sample, and here's our first sample image up on the screen. Now, something you'll notice, the histogram at the bottom, there's actually a blue histogram and a white histogram. The white histogram is actually the original histogram from the images taken and unstretched. The blue histogram is the stretched version. This is a screen stretch only. No changes are actually made to the data, and this is what we're calling the software bisque heuristic screen stretch. I'll talk about the algorithm in a later video when we talk about it, but essentially you shouldn't need to make any adjustments. You just take a picture and things should show up and be visible and not be too terribly noisy for you automatically. In the upper left hand corner you'll see a green box. This is the zoom rectangle, and it's going to show you how much of the image you're currently looking at. Just the green box means you're looking at the entire image. If you click the plus sign or use the mouse scroll wheel, you'll see the green box gets smaller. You can pan around by clicking and dragging the image. And there's also, if you're on a tablet and you can't click and drag, there's some button icons. You can scroll left and right, up and down. And so this is just a convenient way to show you where you are in the image as a whole. We also have three pieces of focusing metrics displayed here that are some people are going to be interested in seeing. The brightest star or pixel in the image is read out in ADUs. Also, the full width half max, both in pixels and in arc seconds, is displayed here. Now, the full width half max may not always be available. It may not be able to compute that if the image is really far out of focus, or if you're focusing on the moon or one of the planets. Those things don't make any sense. Also, the full width half max in arc seconds is not going to be accurate unless you've run the imager characterization wizard so that we know the pixel scale. Also, I just want to remind you the full width half max display is merely a convenience. That value is not used at all in the focusing computation. We're actually using a fast Fourier transform based focusing approach that measures the bunch of scientific mumbo jumbo anyhow. But you will notice as you're focusing the full width half max, if you're on stars, it does get smaller, and that will give you some indication of how good your focus is. Or really, truthfully, it's really more of an indication of how good your seeing is, because once you're in focus regardless of how bad the seeing might be. Now, once you're zoomed in on a region of interest, if you want to use this as your focus area, and this looks like a pretty good spot because we have a couple of stars that are visible, just simply click on Set Subframe to Current View, and it'll set a region of interest or a subframe just around this rectangle, and that can greatly speed up download time for the image, and it will speed up the focusing process quite a bit. Now, of course, you can also set a step size and move the focuser manually. Say move it 100 steps forward or backwards. Take another sample, and it will take another image and display the information. The star will either get smaller or larger, and hopefully the pixels brighter and brighter as you get closer to focus. And so you could focus this way manually. Really, this is more of a diagnostic tool to determine if you need to move your focuser just a few steps or move it 100 steps or 1,000 steps. It really depends on which focuser hardware you have. Now, before you can autofocus, you need to go to the wizards and run the Characterize Autofocuser wizard. Now, there are three ways to characterize your autofocuser. The most technical and the most accurate is if you know the focal ratio of your OTA and you know the focuser step size in microns, you can key those in here and click Compute search size, and it'll compute that for you. It is a function of the critical focus zone. If you don't know the micron step size of your focuser, many focusers will publish that as part of the focuser specifications, or you may be able to measure that with a micrometer. That's probably the best and most accurate if you're technically savvy, that is. The other way, of course, is you can also select the step size manually. There are several options here. It depends. I have a focuser where I have to move it 1,000 steps before you can see hardly any difference, and I have other focusers where 50 steps is a huge difference. If you can determine this value sort of empirically. A minute ago we moved the focuser about 100 steps and we saw a noticeable change in the size of the out of focus star. So 100 steps or 150, somewhere in that range, we know is pretty reasonable. Now down the road, and hopefully very soon, we plan to have a completely automated wizard, so that you just click here and it'll automatically take some images, moves the focuser back and forth. It'll be a very, very slow way of coming to focus the very first time, but it will characterize your focuser and it'll figure out how far to move the focuser each time it's doing a search, and it'll compute that optimally. The shortcut to that, of course, is if you know, again, the focal ratio and the step size of your focuser, you're good to go. For the technical preview, I'm hoping most people will know about how far to move their focuser, or savvy users will be able to sort of translate the focusing parameters from @focus2. Basically, in @focus2, every time the focuser moved as it was tracing out the focus curve, about however much that movement is should also work for @focus3. Maybe potentially a little bit smaller, but that'll work. That should work very well. Now once you save the parameters, it's going to remind you that you need to be focused before you can run the image or characterization wizard, which is typically done as part of the initial setup. Now to get focused, we just go back to the focus tool, and just a reminder, we've got a short exposure. Bin mode is 2x2, which we should always use for color cameras, and simply click autofocus and stand back and it will do its thing. It'll of course back the focuser up and start taking some images, and it will proceed, and you'll be able to see here. I'm going to speed up the video in a second so you can see that the star gets smaller and smaller as it gets closer to focus, and at some point we get past focus, the star gets bigger and bigger, and at that point @focus3 has all the information it needs to compute the ideal focus position. Now if you want an inside peek at what's going on inside of @focus3, you can always click on the Activity tab and see the messages scrolling by. If anything goes wrong and @focus doesn't work and you need to send me a log, this would be very useful to figure out what's going on. Please do not report every time you see range error or any other number of sorts of things. Only if focus failed is there a real error going on. Range error is it's a technical term and it's not really an error. These are just my own diagnostic messages from the engine coming back to tell me what's going on. If you follow through, you can see, like down at the bottom, it didn't find a match in the range it's sampled so far, but it can tell it's getting closer to focus, so it just keeps going. And so the engine is being very verbose in order to assist us, in figuring out what's going on. So meanwhile, @focus3 continues to chug on, and you can see the star gets smaller and then slightly larger. That means it's got some samples on either side of good focus, and it'll compute the best focus position and go there. And you can see here I've got a pretty good focus for tonight's skies. Once you've come to focus, if you haven't already, run the one-time Characterize Imager wizard in the setup wizards. What this does is it takes an exposure and it determines the plate scale or the pixel scale of your optical system, and that comes in very handy for figuring out a lot of things down the road, and it'll help speed up ImageLink and things. If it can't get enough stars in a very short exposure, then it will actually gradually increase the exposure time up to about 10 seconds. After about 10 seconds, if there aren't enough stars in the image to try an image link, then perhaps find an area with more stars. Or I might even be crass and say uncover your telescope, because how did you come to focus in the first place if there are no stars in your image? But we'll see once this is out in the wild how creative users can be at finding ways to make this fail that we didn't anticipate. But I think this should work most of the time. So that about wraps it up, the whirlwind tour of @Focus 3 and the SkyX LTI. It will focus on just about anything, provided there's a little bit of signal. Works great on single stars, star fields, galaxies, clusters, emission nebula, reflection nebula, targets indoors on cardboard boxes, the moon, planets, sun, anything that you can point it at. And we're looking forward to seeing what you can do. Also, in a coming up video, you'll see that for the new Take Series functionality in LTI, you can also insert an @Focus 3 run as part of your Take Series, and that works really great. Thanks.